Okay, so next steps are going to be very similar to flood and learn. Next, we're going to map the VXLAN to the VLAN. Okay, so it's the VN segment under the VLAN config mode. So we already have this done from our previous example, which was flood and learn. So if we look on 5K1 and 5K2, let's look at the show run pipe section VLAN. Okay, so we have VLAN 10 is mapped to VN-segment 11110. Okay, same is true on 5K2. Okay, so same number. We're then creating the Network Virtualization Edge interface, the NVE. Okay, again, on this platform, it's interface NVE0. So if we look at the show run interface NVE0, or NVE1, excuse me, we're saying the source is the loopback. We're saying the VNI membership, okay, in this case is 11110. We specified the multicast group. So again, it doesn't matter what this is, it just has to match between the two. Okay, so both of them are using 228.9.10.11. And then the next change here is going to be to specify that BGP is going to be used as the control plane. So we say host reachability protocol BGP. This means that when we check the ARP cache, we're going to be checking against BGP for the mapping between the IP addresses and the MAC addresses. Okay, so this goes under the NVE interface. So interface NVE1, host reachability protocol, host-reachability protocol is BGP. Okay, so there's only one option there. Okay, same thing over here. Okay, now we're going to have the actual BGP config. So we talked previously about some of the rules of BGP peering and how iBGP works differently than eBGP. In this example, we're going to use iBGP with route reflection, and then we'll come back later and talk about some other possible more advanced designs where we have multiple fabrics that are peering together with eBGP or peering together with route reflector clusters. Then it starts to be a little bit more involved in, you see the similarities to an MPLS layer 2 or layer 3 VPN config. In our case, it's going to be fairly straightforward, where we're just going to enable the address family from the leafs to the spines. The spines are going to be the route reflectors, and then the leafs are going to automatically generate the route target and the route distinguisher values that are advertised in the BGP routes that are ultimately going to include the MAC addresses. Okay, now with the address family, we need to make sure that we're also including extended communities because the route target value is encoded as an extended community. Okay, the same as it is in MPLS L3 VPN or L2 VPN. It's basically the same exact logic. Okay, that we're going to import and export the route from the local table, which in our case is going to be the MAC address table, into BGP. So we're exporting the route out to BGP and then importing it from BGP back into the MAC table. Okay, but we're only going to do that if the route targets values are matching. Okay, so in our case here, again, if we look at the show IP route pipe to include /32, we do have /32 routes to the spines. Okay, this is from the leafs point of view. So on the leafs, we're going to say we have router BGP1. Okay, actually first we'll say feature BGP. Router BGP1. Neighbor is going to be 11171. Their remote AS is 1. The update source is the bag 0. The address family is L2 VPN, EVPN. Okay, in the case of a virtual private LAN services, if feature MPLS was on, address family would be L2 VPN and VPLS. But in this case, it's for VXLAN as opposed to multi-point bridging. But behind the scenes, it's the same type of logic as going on. Okay, for L2 VPN, EVPN, we want to send communities extended. Okay, so if we show run BGP, we're peering with them and activating that address family. Okay, same is going to be true of the other neighbor. Okay, there's a remark here, is this similar to PBB EVPN? Exactly. Okay, PBB EVPN is the next generation of VPLS, that it's using BGP to advertise the MAC addresses in that new L2 VPN AFI format. That's exactly what VXLAN EVPN is doing here. The difference, though, is that instead of encapsulating the data plane in MPLS, you're encapsulating the data plane in UDP. And if you think about the design advantage of that, it means that you can run it over whatever transport you want. Okay, in MPLS, you can only run it over the MPLS network. Okay, so you have to buy that service from the service provider. But with VXLAN, you can extend your layer 2 footprint however you want, or your layer 3 footprint. I mean, you can do both layer 2 bridging and layer 3 routing. As long as you can do a multi-hop here and ping the other guy, that's the only requirement in the underlying transport network. Okay, so we're going to have another neighbor here. Neighbor is going to be 11172. and we're pairing with them as well. Okay, so let's say show run BGP, and then we're just going to copy and paste this onto 5K2. Okay, actually one more thing. Under router BGP1, log adjacency changes, or log neighbor changes. Show run BGP. Okay, so same thing here. Okay, we're then going to take this config and modify it a little bit from the route reflectors. Okay, so this from 7K1's perspective, this is going to be 11151 and 11152. And then for the peering to them, we're going to say that they are route reflector clients. Okay, otherwise the config is identical here. Okay, let's make sure we have logging enabled everywhere. Logging monitor, or terminal monitor. Okay, so in 7K1, we have our BGP config, same thing on 7K2. So really, this doesn't have anything to do with VXLAN. This is just underlying general BGP. The only thing that's different from a global BGP design versus this is that you're just activating a different address family. So all the underlying BGP rules are still going to apply. BGP attribute manipulation is still going to be the same. BGP path selection is going to be the same. The other features like BGP PIC for convergence, or BGP best external, BGP diverse route reflector, stuff like that, all of that is going to carry over to these AFIs. It's just assuming that, you know, not only do you need to know the data center knowledge now, but it's also underlying BGP routing in order to implement a solution like this. Okay, which unfortunately is kind of the hard sell portion of this technology sometimes, is that it's not as common for data center engineers to know BGP as compared to maybe enterprise or service provider guys. Okay, so let's show BGP, L2 VPN, EVPN summary. Okay, those are going to be our peerings. Okay, so now the peerings are up. Okay, this is going to be our main verification from a BGP point of view. Show BGP, L2 VPN, EVPN summary. So did the peering occur to the other neighbor? It's the same as saying show IP BGP summary, except it's for a different address family identifier. So we say show BGP, what's the AFI? AFI is L2 VPN. SAFI is EVPN, and we want to see what the peering is. We want to see the summary. Okay, so I'm not going to get into the packet level detail of the BGP capabilities exchange. If you were to do a capture in line here and then look at the BGP config, you would see that just they're negotiating whatever that new AFI, SAFI is. Okay, you can also see this if you just say show BGP neighbors. Show BGP all neighbors. And then under capabilities, capability of L2 VPN, EVPN is both advertised and received. Okay, so we did both negotiated. Okay, so next step is we're going to advertise our MAC addresses into BGP. Okay, you can think of this like doing a network statement or doing redistribution when you're doing any other BGP config. The difference is that we're taking a MAC address that is going to be inside the VXLAN network ID, okay, in our case 11110, and we're going to generate BGP routes about that. Okay, so first let's look at the MAC address table of the 5Ks. We show MAC address table for VLAN 10. We see the local address. Okay, we don't see the remote addresses currently. And if we go to the servers, we should see that currently, let's look at an IP config, pipe defined IPv4. We're going to ping to 10.0.0.12. Okay, right now we should see that we do not have transport between the servers. Okay, reason why is that the control plane's not yet built. We can't receive the ARPs between them. Okay, before we start this also, or before we finish the final step, let's go to Wireshark on server 2. Let's restart this, capture, and we're going to filter this for BGP. Okay, I want to show what the BGP advertisement is going to look like once the MAC address is advertised. Okay, so what we do is we're going to say under global config, there's a new sub-configuration mode, which is EVPN. Okay, so 5K1, under global, we're going to go to EVPN. Okay, under here, we specify which VXLAN network identifier are we talking about. Okay, our VNI is 11110. Feature segmentation is not enabled. Actually, no. What did I say? VNI. I missed a keyword. VNI 11110. 11110 is layer 2. Okay, layer 3 we'll talk about later. Okay, under here then we specify what is the route distinguisher and what is the route target. Or in other words, we're generating the BGP route. We're generating the VPN route. But in this case, it's an L2 VPN, EVPN route as opposed to like an MPLS L3 VPN or L2 VPN route. But the logic is exactly the same. We're taking the MAC address, we're prepending a route distinguisher that's now making that MAC address unique. So if two customers were to theoretically have the same MAC address, and we advertise them both into the BGP table, that's going to be okay. Because each VNI is going to have a separate route distinguisher, which is telling them apart. Okay, we'll also see that you don't even need to set these. You can just say route distinguisher is auto, and the route targets are both auto. Okay, import and export policy. If we look at the show run EVPN, show run section EVPN, pretty plug and play. Okay, what it's going to do here, we'll see, is going to generate the route distinguisher and the route targets based on the BGP AS number plus the VNI number, because the VNI number is already globally unique. Okay, if we go back to our packet capture, we should see that there were BGP routes generated, which 5K1. Did I not hit enter? There we go. There's the BGP updates. Okay, so we saw after keep alive there was update. Okay, let's see what the first update is saying. So the update came from 11151 going to 11172 and 11151 going to 11171. Okay, so this is the leaf telling both of the reflectors about the new update. Okay, let's look at specifically the details inside of this. Okay, it is a BGP packet, so it's Ethernet with IP inside of it, with TCP inside of it, with BGP. Okay, so it's protocol, or it's port 179. And then if we look inside the BGP update message, there should be multi-protocol BGP reach. Okay, reach and LRI, so we're adding a route. Okay, as opposed to unreach, which would be a withdraw. It says the address family is L2 VPN VPN, number 25. The sub-address family is EVPN. Okay, so L2 VPN EVPN 25/70 is the AFI/SAFI. We then would see what is the NLRI. Okay, so what's the route we're advertising? We're advertising a MAC address. MAC address we're advertising is this one here, 001B 21 8D 3D 98. In addition to this, there's a route distinguisher value set. The route distinguisher is 111151, which is the VXLAN tunnel endpoint. Okay, in addition to this, there should also be extended communities that are included with the update, okay, which is here. In the extended communities, we have the encapsulation. We're telling them that we're going to use VXLAN. And then we have our route target value is where? The target should be an extended community. We should see 11110 somewhere in here. It may be, let me see, let me go down a little further. Route refresh update. I think it was because there were two steps in when I had configured it. So let's see, what does the route refresh say? The route refresh is probably adding the target value. Route refresh update, extended communities, there it is. Okay, so under extended communities, it's saying that your route target is 1:11110. This is the BGP AS number followed by the VXLAN network identifier. This is how we figure out what routing table, or essentially MAC address table, that entry belongs to. So there was that question before, is how does the leaf figure out where the MAC address belongs? There's two different ways. In the control plane, it's based on the BGP route target. In the data plane, it's going to be based on the VXLAN network identifier, based on the VNI. Okay, so long story short, the MAC address gets advertised into BGP. Okay, you don't necessarily need to know the details behind the scenes, but this is what's going on, is multi-protocol BGP. Okay, once that advertisement happens, if we look at the show MAC address table, the end result is going to be the same as before. That we know about the MAC, and it's reachable via the network virtualization edge interface going to the VTEP. Okay, the VTEP is 11151. Beyond this, though, if we look at the show BGP, L2VPN, EVPN, we see now that we're advertising the MAC addresses into BGP. So these are going up to the reflectors. The reflectors are 7K1 and 7K2. If we look at the show BGP, L2VPN, EVPN, we have those routes. If we show MAC address table for VLAN 10, notice that the spine switches don't need to know the final destinations. And this is the key optimization of the control plane, that even though they have the route in global memory, they're not actually installing it in the FIB. They're not installing it in the forwarding engine. And if we think about the general purpose CPU, if we look at the show version, this box has what? 32, no, that's not what I'm looking for. Yeah, that's right, 32 gigs of RAM. Yeah, that's in kilobits, not in bytes. Or kilobytes, not bytes. So the box already has tons of memory. So this is more than enough than you would need for any possible number of MAC addresses, up to whatever the scaling limitation is going to be of the overall feature. But you only need to install them in global memory. You don't need to install them in the TCAM. You only install them in TCAM if you actually have the VLAN configured. Okay, so what I mean by this is, let's say that we were to have another VNI. Okay, so let's say we go to 5K2 and we show interface status. We're going to take this port here. We're going to put this port in VLAN 20. So we're going to create VLAN 20. We're going to say it's VN segment 111120, or actually 11120. It doesn't matter. Okay, anything here. So 11120, and we're then going to show run pipe section EVPN. Okay, under EVPN, we're going to generate a route for it. So VNI is 11120. It's layer 2. Route distinguisher auto, route target auto, import and export. No VLAN ID configured, unable to generate route auto route distinguisher. Why not? 11120, 11120. And this, I think it means that I don't have it configured at the NVE. Interface, NVE1, member, VNI, 11120. Multicast group, whatever, 224.444. Show CLI history, unformatted, pipe to show me the last 10 lines. Okay, this here. So under EVPN, okay, we're advertising that segment. So then we're going to go to the interface, switch port host, switch port access VLAN 20. And let's show MAC address table for VLAN 20. Okay, we have the end host. Okay, it's 3D99. We should see now the end result of this is that we're going to generate a BGP advertisement for VLAN 20. So if we show BGP, L2VPN, EVPN, and look for 3D99, okay, we can see it's in there. If we wanted to see the details of this, we would say for the prefix in this case being the MAC address. Okay, here's the specifics of the BGP route. So just like any other BGP advertisement, we have the weight, we have the local preference, the AS path, origin, med. Then we have the label and the route target. Okay, these are matching the VXLAN network identifier. Okay, this belongs to segment 11120. We then advertise this up to the reflectors. We go to 7K1 and look at the show BGP, L2VPN, EVPN. We should see that we have that advertisement, the 3D99. Okay, if we go to 5K2 and look at the show MAC address table for that address, okay, that's the one that's installed locally. It should be, which it is. If we look over on 5K1, 5K1 will not install this. The reason why is it does not have that VLAN to VXLAN mapping configured. Okay, additionally, if we look at the show BGP, L2VPN, EVPN, it's not receiving that route. Okay, if we look at it from the reflector's point of view and show BGP, L2VPN, EVPN neighbor, 11151 advertised routes, we are advertising the route to them. Okay, the 3D99. If we go over to 5K1, and let's look at the same show output as before, which was the route, show BGP, L2VPN, EVPN for that address. Okay, let's go to 5K1, look at the same output. It says it doesn't have it. Okay, if we look at on all 4 of them, everyone besides 5K1 has that route installed. Why would that be the case? Any guesses? Okay, let's look back at the diagram. So between 5K1 and 5K2, this guy has VLAN 10, which is VNI 11110. This guy has the same thing. VLAN 10 is VNI 11110. It also has VLAN 20 that is VNI 11120. Okay, we're advertising the routes to the reflectors. Okay, so both of these are route reflectors for address family L2VPN and EVPN. And they are advertising it back down to the other side. So 5K1 is receiving this route, but it's not installing it in the BGP table. Okay, this works the same way as L3VPN and MPLS or L2VPN and MPLS. When the route comes in, you check the route target value. If that does not match a local mapping to your local VNI, you throw the route away. Okay, that would be the same logical equivalent of does it match your VRF in the case of MPLS L3VPN? Or does it match your VPLS identifier in the case of L2VPN VPLS? So it's an automatic efficiency mechanism of the control plane that the leafs only accept the routes that they actually need to forward down towards the end hosts. So at a later time, if we were to add VLAN 20 in there, then we would re-import the route. Okay, so on 5K2, let's look at the show CLI history unformatted pipe to show me the last, let's say 40 lines. And what I want to do is go to the NVE. I'm going to add the new member. Okay, then under EVPN. Okay, so actually I need to create this first, which is going to be this. And let's paste this on 5K1. Okay, if we look at our previous show command, what we should see here shortly is now we do install the route. If we show MAC address table for VLAN 20, we now know about that destination. Okay, let's do the same thing for another prefix. So let's say that we have VLAN 30, 11130, and then we're advertising it. Okay, and before we do this, we're going to look at some debugs. Logging monitor 7, terminal monitor, and then debug BGP updates. There's debug BGP updates. Okay, and then let's apply this new VLAN to the other side, VLAN 30. Okay, from 5K1's point of view, it should get a BGP update in a second here. Actually, there's no MAC addresses yet. Let me do this. Let's go to the access port, interface E11, say switch port access VLAN 30. Okay, now our 5K1 gets a message. So it says that we are, and let me copy this. You can see it's a lot of output to kind of sort through the debug of the updates. But what we're looking for here is that it received the route. So it withdrew the old route. Then there should be a new update coming in. This here. Inbound import route target check action deny. And it should also say here for some reason that it says it's being rejected due to policy rejected. Okay, what this means, and a couple people had mentioned it here, it's the same exact thing as route target filtering. Okay, it is route target filtering, but it's the same thing that would happen in L3 VPN, like for inter-AS. Or basically, when I advertise you a route and you don't have that VRF configured, you wouldn't accept it. Okay, same exact thing is happening here with L2 VPN, EVPN, except I'm giving you a MAC address route, and you don't need the MAC address because you don't have the VNI configured. So that's the reason why, and someone had asked here, is it a good idea to manually configure the route target? It's actually not a good idea to manually configure the targets. The reason why is that the target is auto-generated based on your VNI. So if we show run section VLAN, we have VNIs 11110 and 11120. This means that when we look at the BGP attributes, we're looking for route targets that are 1:11110 and 1:11120, and we're only going to import those prefixes because the numbers are auto-generated based on your BGP AS and then your VNI number. The only case that you would want to manually set it is that if you need to do some sort of translation between like the BGP ASs, and we'll look at that later when we talk about using eBGP to route the fabric in larger scale designs, where you have multiple fabrics you're trying to connect together. Maybe you're trying to do data center interconnect and you're peering eBGP over the DCI link, and you want to use BGP EVPN as the control plane. But with this design, with the route reflector, there's not a ton that you really need to do other than, or beyond the flood and learn, I should say. The only thing that's really changing in this config is that under the NVE, you're saying use BGP as the reachability protocol. Then, of course, we have the BGP config itself, which is going to be doing the peering and enabling the address family L2 VPN, EVPN. But notice here, when I said show run BGP, what did it also include? It also included the EVPN config. So at least for me personally, I think it would have made a little bit more sense if they had put this under the BGP configuration, because this is basically the same as going to a VRF in L3 VPN and then doing like redistribute connected, which what you're redistributing here is the MAC address table. But the EVPN config here is really a subset of BGP. It's saying create an advertisement of your MAC addresses that are in VXLAN network ID 11110, advertise their layer 2 addresses, and when you create the advertisement, set the route distinguisher and the route target based on your VTEP, so based on your loopback, and then also based on your BGP AS, and then your VNI, the VXLAN network identifier.